There are four main ways to traverse a tree. The first is a breadth-first search traversal, also known as level order traversal. The second is depth-first search pre-order traversal. The third is depth-first search in-order traversal. And then the last is depth-first search post-order traversal. So starting with breadth-first search, a breadth-first search traversal visits all the nodes of a level before moving on to the next level. So we can break these up. Let's break up our tree into levels. We'll start with the root node, which is 4. And then we will visit all nodes of a level before moving on to a new level. So we start with 4. That's the only node in that level. Then we move on to 2, then 5. We've now looked at all the nodes in this level, and we can move on to the next level, 1, 3, and 6. And so our order would be, if we're going from left to right, which is the conventional way of doing things, you can go from right to left as well. But from left to right, it is 4, and then 2, 5, and then 1, 3, 6. So 4, 2, 5, 1, 3, 6. So that is breadth first search. By the way, these yellow lines represent null nodes. So sometimes you don't even see these lines. Sometimes they don't exist. But right here, they are representing null nodes or null children. So there's nothing here at the end. It's just null. Okay, so now let's look at depth first search, the 3 depth first search traversals. So when traversing a tree, when doing a depth first search traversal, we're going to explore as far as possible along each branch before backtracking. So instead of going level by level like we did with breadth first search, with depth first search, we're going to go down all the way and basically wrap this entire tree, just like this. Okay? And we're going to continue on the whole tree. You could start on the right side, but conventionally speaking, traditionally, you start on the left side and you traverse all the way until you're coming up the right side. So the difference between the 3 types of depth first search traversal is at which point we visit or at which point we process each node. So when it comes to pre-order traversal, that's what we'll do first. When we're doing pre-order traversal, we'll start on the left side, and the first time we see a node, we will process it. So boom, we just passed by 4. We just saw 4. Okay, we'll process it. Then we pass by 2 for the first time, so we'll process it. We pass by 1 for the first time, so we'll process it. And then we go to 1's left child, it's null, so we come back to 1, so that's us seeing 1 for the second time. Then we go to 1's right child, then we go back to 1 for the third time. But remember, we only process it the first time we see it, not the second, third, or however many other times we could see it. In this case, by the way, every node will be seen 3 times. So 1, 2, and 3. And that's because this is a binary tree. There's two potential children that any node can have. And so that means that if you're traversing it, because it has these 2 kind of wings here, you'll pass or visit each node 3 times. And so we'll see that as we continue. So we see 2 now for the second time. We don't do anything. We see 3 for the first time. Okay, we process it. So we process it. We go to 3's left child. We go to 3's right child. Back to 3. Back to 2. Back to 4. And then we see 5 for the first time. So we process it. And we go to 5's left child. Back to 5. We see 6 for the first time. We process it. And then we go to 6 left child, 6 right child, back to 6, back to 5, back to 4. And our order is 4, 2, 1, 3, 5, 6. Okay, so that's pre-order traversal. The first time we see the node, the first time we come across the node in our traversal, we process it. Okay. Now, in order traversal. So in order traversal, we will process the node the second time we see it. So let's start our traversal process. We're coming down. We see 4 for the first time, so we don't do anything. We see 2 for the first time, we don't do anything. 1 for the first time, we don't do anything. And then we go to 1's left child, we go back to 1, and boom, that's when we process it. So we've got 1 now. We go to 1's right child, back to 1 for the third time, we don't do anything. Now we see 2 for the second time, so we process it. Then we go to 3 for the first time, we don't do anything. 3's left child, then we go back to 3, process it. We go to 3's right child, back to 3 for the third time, back to 2 for the third time. Then we hit 4 for the second time, so we process it. We hit 5 for the first time. We go to 5's left child. We go back to 5. We process it. We go to 6 for the first time. We hit 6's left child. We go back to 6. Then we process 6. Then we continue on. We go to 6's right child. Then we go back to 6 for the third time. Back to 5 for the third time. Back to 4 for the third time. And that is in order traversal. So we've processed each node the second time we came across it. And as you can see, that second time is always in between the left and right nodes. So that is in order traversal. Also, it's worth mentioning that if you look at the order of the in order traversal, the numbers are actually in numerical, ascending numerical order. 1, 2, 3, 4, 5, 6. And the reason that is because this right here is a specific type of tree called a binary search tree. And what that means is that any given node in the tree's left subtree, the elements in that subtree are going to be less than the node, and then the elements in the right subtree are going to be greater than the node. So 2, 3, and 1 are less than 4, and then 5 and 6 are greater than 4. And if you look here, it's the same rule applies for any node in the tree. So if you look at 2, 1, which is its left subtree, is less than 2, and then 3, which is its right subtree, is greater than 2. So that's what a binary search tree is. And if you are traversing a binary search tree and you want to collect the values of the nodes in order, in ascending numerical order or ascending order, you can use in order traversal. Depth first search, in order traversal. By the way, if anybody says pre-order traversal, in order traversal, or post-order traversal, they're referring to depth first search. They're just excluding saying depth first search. Okay, here is the last type of traversal. So post-order traversal. We'll do the same thing. We'll wrap our tree, and it'll be the last time that we come across any of these nodes that we're going to process them. So we see 4, 2, 1 for the first time. We look at the left and right nodes of 1. We pass by 1 for the last time, so we process it. And we pass by 2 for the second time, 3 for the first time. We look at left and right nodes of 3. We pass by 3 for the third time, the last time, and we process it. Then we pass by 2 for the last time, then we process it. So it's after checking every node's, all of the node's children, that we process it. And so we pass by 4 for the first time, or for the second time, 5 for the first time, check 5's left node, It's null. We go back to 5. We pass 6 for the first time. Check 6 left and right nodes. Then we pass by 6 for the last time. We pass by 5 for the last time. And then we pass by 4 for the last time. And that is the order in which we process the nodes. So naturally, you might be wondering, why is it that we're saying it's the last time and not the third time? Well, the reason is because this is a binary tree, right? Each node has up to 2 nodes. But what if this tree had 3 children per node, right? What if every node could have up to 3 children? Well, then when we traverse, we would potentially see a node 3 or 4 separate times. We would pass by a node 4 separate times. So it would be that last time. This is kind of a mess, but it would be the last time that we pass by a node that we process it. And so that's why it's the last time and not the third time. So I hope that makes sense. Anyway, those are the 4 main ways to traverse a tree.